All right, folks, it's Bass Action back in action here. On this page of notes, we're going to cover complementary and supplementary angles and also vertical angles and linear pairs. So we're just going to jump straight into some examples. On our first example, we're given that A and B are complementary. So as we've been doing throughout these videos, we're always highlighting our keyword that tells us how to set up our equation. Complementary tells us that they're going to add to 90 degrees. So we're going to jump straight into that algebra. We're going to have our 5x minus 28 plus our 2x minus 1 equals our 90. Gives us our 7x minus 29 equals 90. 7x equals 119. And we're given then that x is 17. We're not quite done with the problem though, because as we've been emphasizing, we always have to read what it asks us to find, and this one wants us to find the measure of each angle. So we're going to take that 17 and substitute it back into either angle. It doesn't matter whether we start with A or B. I'll go with A just because it's alphabetical. So if I'm looking for the measure of angle A, I'm going to have my 5 times my 17 minus my 28 gives me 57 degrees. Now, if I want, I could simply take that 17 and substitute it into angle B, but I could also, for angle B, just do 90 minus 57, because I know they are supposed to be complementary. And I'll get 33 degrees for that one. On our next example, I like having these two examples side by side, because on the next example, instead of giving us direct expressions for each angle, it gives us a relationship between the two angles. So as we read it, what we're going to find is that the measure of the angle, instead of giving us that expression, like I said, it tells us is 20 more than 4 times, and it tells us the supplement. So we've just got to read that very carefully, and then in the end, we're going to have to actually find the measure of each angle. So we know supplementary angles, oops, hate it when I do that. Supplementary angles are going to add to 180. And what I like to do on this is I like to actually write blank plus blank equals 180. I like to do that because it helps me remember that I do need two specific angles. So the first angle is going to be x, which makes this example dramatically different from the first one, because once we solve for x, we actually have one of our angles, but we didn't have that in the previous example. Then we can write the expression for the second angle. It tells us that it's 20 more than 4 times, and it's always going to be easier for us to start with the multiplication. So I'm going to go with the 4x, and then it's 20 more than that. Now the algebra gets pretty simple. So I'm going to have my 5x plus my 20 equals my 180. 5x equals 160, and my x is going to be 32. That actually turns out then to be one of my angles, because in my setup I can see that one of my angles was just x. So the second angle, if we want to find that second angle, which we do need to do, I'll call it angle 2. I'm going to say the measure of angle 2 then is simply going to be that 180 minus the 32. Again, you could substitute back into the expression that we made, or you can just do that subtraction and get the second angle as 148. Now in the next two examples, we're going to work with our pictures and some expressions here. And on each of these ones will be a little bit faster for us because all we have to do is solve for x. One of the things we talked about in class when we're trying to identify linear pairs and vertical angles was a little bit of a color coding. Some students identify the angles very easily, others sometimes struggle with this. So just remember the little trick. When you see these intersecting lines, okay, has to be two intersecting lines. When we see that, we can do some colors. So I'm going to put a dot in one, and then I'm going to alternate my colors as I go around. Matching colors will give me congruent angles. Non-matching colors will give me angles that are supplementary. So that's just kind of a little trick to help you identify visually those linear pairs and vertical angles. So in our first one here, we're working with angle 1 and angle 2. And from our picture, we've got two different colors, so we should be able to visually see that angle 1 and angle 2 are a linear pair, so they are in fact supplementary. And of course, if they're supplementary, they add to 180. So let's go ahead and do that algebra. We have our 7x plus our 20 plus our 5x plus our 10 equals our 180. So I'm going to get my 7x equals, oops, meant to say 12x there. I lost my 5. Sorry about that. 12x equals 150. And we could write that as a fraction, or in this case, I'm going to go ahead and write it as a decimal for us. I'll be really specific on the test whether I want decimals or fractions. On the next one, our angle 1 and angle 2 are the matching colors, or visually we can see that those are vertical angles. So if angle 1 and angle 2 are vertical angles, then we automatically know that they are congruent. So we can just set those two expressions equal to each other. 3x plus 20 equals 5x minus 50. I'm going to go ahead and move my variables to the right. I'm going to get a 2x on that side. I'm going to get a 70 on the left. So I get x equals 35. All right, so those are pretty much what most of our examples are going to look like. Sometimes our pictures will get more complicated than others, but this is a good flavor of what to expect. Now, the next thing that I want you to think about, and you might need to flip back to the notes we did in class for our vocabulary, is this reflection piece. The reflection piece is really going to help us connect our vocabulary and help move our ideas to our long-term memory. I want you to take a look at examples 3 and 4, also look back at the vocabulary in class, and explain why a pair of angles cannot be both a linear pair and a pair of vertical angles simultaneously.